Hello, everyone. My name is Xie Ming, and I come from Nanyang Technological University. First of all, I would like to thank you for coming to today's festival. All of you may know that the Skill Future is an initiative or a program which is heavily supported by the Singapore government. If you are employee, Skill Future will help you to grow your knowledge, to sharpen your skill, and to secure your job. If you are employer, Skill Future will help you to enlarge your view in your business world, to open your mind in your emerging market, and to empower the workforce in your dynamic company. I hope that all of you will find today's festival very fruitful. At the least, you should be able to gain some input which will allow you as an employee to align your knowledge and the skill with the future trend in industry and the society, or allow you as an employer to align the knowledge and the skill of your workforce with the future trend in industry and society. Secondly, I would like to thank the organizer of today's festival for inviting me to deliver today's public talk. In today's talk, I would like to share with you my thought and viewpoint about the answer to this question. What should be the future trend in manufacturing, or what should be the industry 5.0? All of you may know that today we are in the era of industry 4.0. Then it is interesting for us to know what should be the next phase in industry. My answer to this question is industry 5.0 should be robot integrated manufacturing. In today's talk, I will try to remain at the philosophical level as much as I can. In this way, you should be able to easily follow my today's talk. The key takeaway from my today's talk include 1 prediction and 3 understanding. In year 2018, we have already predicted that the industry 5.0 should be robot integrated manufacturing. The 3 understanding include: number 1, to understand the nature of robot and robotics. Number 2, to understand the nature of manufacturing, which include 3 types of manufacturing. They are mechanical manufacturing, chemical manufacturing, and biological manufacturing. In particular, the understanding of biologic manufacturing will help you to understand the nature of evolution, because evolution is another big topic, all right? And number 3 understanding is to understand the trend in manufacturing. Some of you may heard of CIM, Computer Integrated Manufacturing. That is Industry 3.0. Today, we heard of Industry 4.0. Actually, Industry 4.0 refers to network integrated manufacturing. Then after Industry 4.0, it should be Industry 5.0, which should be robot integrated manufacturing. All right, so these are the key takeaway from listening to my today's talk. Before I enter today's talk, let me give you a quick introduction about myself. All right. I did my master degree and a PhD degree in France under the overseas scholarship from Chinese government. And I joined Nanyang Technological University in year 1993. In year 1999, I reached the rank of associate professor. In year 2003, I have published this textbook on fundamental of robotics. In year 2021, that is last year, I have published this book on new foundation of artificial intelligence together with two other authors. In year 2004, we have launched this international journal of humanoid robotics together with another two called Editor-in-Chief. And around the year 2008, we have developed this full-sized humanoid robot with financial support from Singapore government. My research focus cover basic research, applied research, and product innovation. And the two keywords underlying my research focus are intelligence and motion. So inside the inner ring, you will see the research topics for my basic research. And in the middle ring, you will see the topics which are related to my applied research. And in the outer ring, you will see my interest in terms of product innovation. All right, so that's a short introduction about myself. Now let's start today's talk. I will focus today's talk on three key points. First, I will try to give you a basic introduction about the robotics. Then I will try to give you a very accurate introduction about the manufacturing. Then I will try to convince you about the future trend in manufacturing, that is toward the achievement of robot integrated manufacturing. So let me start with basic introduction about the robotics. Actually, if you want to have a full understanding about the robotics, you need to spend at least 1 semester to study in the university. All right. So here I'm going to spend about 10 to 15 minutes to give you a very, very basic introduction about the robotics. All right. So all of you know that we are the most advanced creature in the universe. If you look at this tree of life on Earth, obviously we are the most advanced one, all right? But this slide highlights to you another interesting question, which is what is the driving force behind the creation of all this life on Earth? All right, today there's a big debate between these two ideas or two theories. One is about the bottom-up evolution, another one is about the top-down design. All right, and some of you may have heard of Darwin's theory of evolution, all right? But today, with advance in science and the technology, more and more people start to believe in top-down design. And interestingly, if you know the nature of manufacturing, immediately you understand what should be the driving force behind the creation of the most advanced creature in the universe or on Earth, all right? And more or less you will believe in top-down design, all right? And we are the most advanced creature on Earth or in the universe. Then the next question will be, what should be the most advanced creature made by human being? Then the answer should be robot, all right? And here I just showing you some example, right? So after today's talk, I guess you will believe in this answer, because if you compare humanoid robot with an aircraft, humanoid robot with a vehicle, or humanoid robot with a boat or ship, immediately you understand humanoid robot is the most advanced creature among all the machine designed by human being, all right? So now we know, okay, robots are the most advanced creature made by human being, and eventually we can make use of a robot to help us to undertake a lot of tasks. Then there is a public worry about the replacement of human labor by robot, etc. All right, then this is a discussion for you to think about. All right, a lot of people worry about the loss of a job or job which will be taken up by robot. Right, then the issue is it our intention to use a robot to replace a human being? If not, what is the purpose of using robot or deploy robot in industry, right? The simple answer for you to understand the issue is to know the nature of manufacturing. Manufacturing is not just simply equal to the production, because in layman term, a lot of people equal manufacturing to production. Actually, manufacturing include 3 phases, which are design, production, marketing, and the sales. All right. So actually, we can free human being from doing dirty, dangerous, and difficult job in production, and let people to undertake more enjoyable job or work, okay, in the phase of doing design, in the phase of doing marketing and the sales, all right? And also the deployment of a robot actually will create new job opportunity, all right? So we should not have this worry about the displacement of human being from undertaking some job in production, all right? So the true purpose for us to make use of a robot actually is to free us from doing these 3D job. 3D, D means first D refer to difficult job, second D refer to dirty job, third D refer to dangerous job, all right, to free us from doing these 3D type of job, all right? And the second motivation is to enhance our physical capability and also our mental capability, all right? Because we are very, very good in inventing tool, in inventing machine, in order to extend our physical capability. And in future, we may make use of a robot to extend our mental capability. So this is a very, very good research and development, okay, for us, okay, to evolve industry and evolve our society and make our life more enjoyable and less painful, right? Since robot will bring in so many benefits to industry and to society, then you may want to know how to invent the robot. All right. So now I'm trying to give you the answer to this question by showing you the history of inventing robot in China, in Western country, in Japan, and eventually in Singapore. All right. So it is very interesting to know that the activity of inventing robot was studied in China. For example, if we believe that the teleoperated robot are part of the robot family, then immediately you understand the first generation of a teleoperated robot was invented in China under the name of puppet or shadow puppet, etc. Right? So here you see some example, and the puppet is very, very popular around the year 600 to 1000. Right? So during that period of time, there were a lot of invention of such teleoperated robot. All right. And now I'm going to play this short video for you to understand what is a teleoperated robot, okay, in the form of puppet. All right.
A long time ago, a monarch missed his deceased concubine so much, he got sick. His ministers reproduced the image of the concubine with cloth and put it behind a screen. The monarch could see the shadow of his concubine on the screen. This was the origin of the shadow puppet, Piying. Piying represents interesting stories with lively songs and shadows produced by lights. It is the earliest animated technique in the world. The images are always made of patterned donkey leather sewn with thread. The bodily movements and facial expressions of the puppets are created by bamboo sticks. Piying tells stories with traditional methods and is popular all over the world. It features not only interesting stories, but also Chinese folk art.
All right, so you will see the invention of first generation of a teleoperated robot was not for industry application, but for entertainment. But this video may give you some inspiration about the creation of a new job with the massive deployment of a robot. For example, we can make use of today's robot to create more such entertainment product. All right, then in this case, we need to make use of human being to create the story and to make use of a robot to realize the story. All right, so this gives you an indication about the job creation by today's robot. All right. And actually, if you look at today's achievement in the area of robotics, immediately you understand the major contribution come from Western country. For example, the terminology robot was born in year 1921. The terminology of robotics was born in year 1941. All right. These two terms were born in Western country. And in year 1942, Russian writer has formulated the three rules for the development of robot or to guide the R&D in robotics. And then you will see the second generation of a tele-operated robot was invented by General Electric in USA in year 1948. And the first company in robotics was set up in USA in year 1956. And up to today, you will see the most advanced humanoid robot in terms of motion behavior was developed by Boston Dynamics, which is a US-based company. All right. So immediately you understand that the major contribution in robotics come from Western country. However, in Asia, okay, we have a special country, which is Japan, and Japan has also made a tremendous contribution to the development in robotics. And later I will show you a slide which will summarize the contribution made by Japan in robotics. Right now, let me play this video, which is about the humanoid robot developed by Boston Dynamics, which is a company based in USA. Okay, So that gives you enough idea about the contribution made by a single company in USA. Just now, I have already mentioned that besides the Western country, in Asia, there is a special country, which is Japan. Japan has made also a tremendous contribution toward achievement in robotics, and especially after the Second World War, Japanese government has made a tremendous contribution to support R&D in robotics. And this is why you see a lot of wonderful result or interesting result come out from the companies such as Sony, Honda, Toyota, and of course, you see among the 4 major industrial companies in the world, 2 of them come from Japan, all right? So then you will see, okay, a small country in Japan has also made a tremendous contribution toward the development of a robot, right? And in this slide, you see the Honda's humanoid robot, right? But it is also interesting to see that Japan has continued the tradition, okay, from China, because puppet was invented in China and in Japan. Then they continue the development of puppet and all the way to achieve today's humanoid robot, right? And this slide just highlight to you the history of inventing humanoid robot by a single company in Japan, which is a Honda. I guess all of you know that the Honda was a manufacturer of automobile, okay? Traditionally, it is not the robotics company. And then you see, okay, this company has invested a lot, okay, to the development of robot and humanoid robot in particular, right? And this video basically showing you some demonstration, okay, by the humanoid robot developed by Honda. Okay, so in terms of skill, I guess all of you will believe that this humanoid robot is one of the most advanced robot in the world, right? So then you see the achievement, okay, made by a single company in Japan, and you can compare this achievement with a humanoid robot invented by Boston Dynamics, which is a US-based company, right? And then how's about the history of inventing robot in Singapore? Relatively speaking, the history of inventing robot in Singapore is not so long. For example, in NTU, the Robotics Research Center was set up in year 1994. And 2 years later, we have developed this humanoid robot, all right? And in year 2008, around the year 2008, we have developed this full-sized humanoid robot. This could be considered as the most advanced robot in Singapore, all right? And if you compare it with robot from Japan, from the USA, from South Korea, and the gap is not so big, right? So we are quite close to the achievement made by USA, made by Japan, etc. Right? And you also see the tiny version of a humanoid robot. And I guess all of you know this gentleman. This is a minister, okay, inside our Singapore government. All right. So this is a replicate of this professor in NTU. So we call this as Android. All right. So just to imitate appearance of a human being. And this is a cleaning robot developed by a local company. And this is a robot developed in Singapore for the purpose of doing food delivery or goods delivery or item delivery, etc. This is a robot for Homeland Security. And this is a robot developed in Singapore for medical application or to be deployed like in a hospital environment, etc. Right? Okay, so this slide basically showing you some video, okay, developed by our research team, right? So here you see human-robot interaction at the signal level or cognitive level, right? And this is a human-robot interaction at the cognitive level, okay? We use a voice to undertake a conversational dialogue with a robot, then instruct the robot to perform a task. This video showing you the level 1 intelligence, which could be reached by today's robot, okay? And this is a typical scenario of doing hand-eye coordination, all right? So today's robot could undertake hand-eye coordination autonomously, right? And this video basically showing you the human-robot interaction at the signal level, right? So the robot has a sensor to sense interaction force, interaction torque, and based on the sensory output, then the robot automatically adjusts its pose or position and orientation, right? Okay, so we move on. Now you may want to know, okay, what is a robot, right? So for those of you, if you have attended the robotic course in the past year, and you know that the original definition of a robot basically refers to industrial robot. And in the definition of an industrial robot, basically we focus on the key concept of reprogrammable machine, which could carry a different type of a tool for the performance of a different type of a task in industry. However, in today's context, that definition is no more valid, right, for the description of today's robot, right? Then here I give you today's version of a definition. So basically, we could consider that today's robot is an embodiment of a body, brain, and the mind, which could undertake these 3 types of important activity. The number 1 activity is to perform or to execute motion. Number 2 activity is to perform a task through the execution of the motion. And the number 3 is interaction, okay, with people. And the third type of activity is extremely important in today's context. And also it is extremely important to the achievement of a robot integrated manufacturing, because in the future scenario, of production line, we may see the presence of a human operator and the presence of a robot. Therefore, it is very important for robot to be able to interact with human being. However, in the old definition of the robot, the interaction between robot and the human being are not so important, right? But in today's context and also in future scenario of deploying robot in manufacturing, the third activity is extremely important. And this slide showing you a typical example of a human-robot interaction at the cognitive level, all right? So in this scenario, in future, human worker may just stay inside the control room and monitor the activity undertaken by robot. Then in this case, it is very important for human worker to have this capability to undertake a conversational dialogue with a robot, which are deployed in the production line for the purpose of undertaking the actual work inside the production line. All right. So this also may give you an idea about the creation of a new job. So it means in future, we may have a lot of control room in which human being serve as a master, all right, just to monitor, okay, the activity of the robot inside the production line, right? So therefore, you understand, all right? It is very important for us to achieve human-robot interaction at the cognitive level. For example, how to make use of a human language, okay, in order to program and reprogram a robot for any specific task, okay, to be undertaken by the robot, etc. Right? So this slide also help you to think about what should be the creation of a new type of a job with the deployment of a robot in industry, right? Okay, so that's about the basic introduction of the robot and robotics, okay? Because the key focus of today's talk is in manufacturing, and in particular is about the robot integrated manufacturing. Okay, so let's move on to give you a basic, more accurate introduction about the manufacturing before we enter into the discussion about this prediction of future trend, okay, in industry, right? So what is manufacturing? Then why does manufacturing matter, right? I guess if you ask people what is manufacturing, why manufacturing is important, I guess a lot of people may say, I know it, but if you ask them to give you a very, very accurate answer, you may receive all kinds of answer, right? So then what should be the exact answer to the question of what is manufacturing, or to the question of why does manufacturing matter, all right? The accurate answer should be manufacturing create value. Then you need to understand what is the value, all right? This is very, very important, all right? In layman term, because actually we do not know the exact answer to this question of what is the value. So actually value means exchangeable result, okay? So inside the answer to this question, what is the value, okay? So we must remember these two pieces of important information. One is to create result. Second one is to achieve exchange. If you produce result which could not be exchanged in the market, then it is a waste. It is not a value. It's like when you run a company, you produce thousands or millions of a car, and all of them could not be sold in the market. then you cannot say that you have a create value. Actually, you create a lot of waste, right? So result plus exchange create value, right? So therefore, you understand, okay? Manufacturing includes 3 phases: design, production, and the marketing and the sale, right? So production, design, basically will create result. Marketing and the sales will achieve exchange. So therefore, manufacturing create value. So if you understand the true nature of value creation, then immediately you understand manufacturing is very, very important in economy, in our society, etc. All right. So exchange means what? Exchange means you must have a seller, you must have a buyer, all right? Then you must have a place for exchange to occur. Then this place is called as a market, etc. Right? Then how to produce result? So you need to have a seller. Seller basically means a manufacturer, all right? So then you must have a person or company which will produce product or offer service, etc. Right? Then buyer means what? Buyer will supply the demand, and tell the seller the current need or eventually the future need, and to see whether the seller could meet the future need of the buyer or not, right? So this is a very important understanding. Also, this understanding are extremely simple. I guess this basic knowledge has been largely overlooked by the public and eventually by some researcher or scientists. All right. And in this slide, then you will see, I believe, result plus exchange should be the #1 law in economics. All right. So it's like in physics, we talk about the Newton's second law because Newton's second law is quite important. All right. Then in economy, so I believe we must talk about the value result with exchange, exchangeable result, create value. All right. It's not just result create value, it's exchangeable result create value. All right. Then how to produce result, how to achieve exchange. Manufacturing is a typical process in our modern economy, right? So this is a very important answer to this question. Why does manufacturing matter, right? And secondly, you understand without the result, then we cannot do exchange, John. Here you see, without the result, how can we undertake exchange? So therefore, it makes sense for us to believe that without the manufacturing, there will be no market, okay? Because manufacturing will sustain exchange, because manufacturing will produce result, all right? And today, if you look at the market, you can identify these 3 segment. We can talk about the market of the manpower, market of the product, market of the finance, all right? And for employee, market of the manpower is very important, all right? Because the market of the manpower will offer job opportunity to those who seek for employment, all right? So without the manufacturing, then we cannot create this market, right? Then in terms of exchange, this is a background knowledge for you to know, okay? It is quite interesting for us to know that actually there are 4 types of exchange, right? We can have exchange between result and the result. We can undertake exchange between result and the currency. It's like you sell a product and in return, you receive money, right, or currency. Or we can undertake exchange between currency and the result. It's like you spend money to buy product, right? So for the 3rd type of exchange, so this is dominated by the buyer. For the 2nd type of exchange, it is dominated by the seller, all right? So I produce result, I sell to the market, all right? But we must pay attention to the first type of exchange, okay? So exchange may occur between currency and the currency. And knowing this type of exchange is quite important for decision maker, policy maker in any country. We must limit this type of exchange. Why? The reason is because the first type of exchange does not need to have any result. It's like you have a Singapore dollar to do exchange with a US dollar. And in this process of exchange, there's no result at all right? And the problem is today, a lot of people are fascinated with these kinds of exchange. To a certain extent, this type of exchange should be labeled as a gambling channel. So government must limit this type of exchange, all right? Because the first type of exchange actually will not create any value at all to the society, all right? So this is very, very important for you to know, and I hope that the general public, okay, will monitor, okay, the financial market and make sure, all right, we will not waste too much resources to the first type of exchange, because the first type of exchange will not create value at all right? Okay, so now come to this question, okay, because now we know manufacturing is very important, because manufacturing will create value, all right? And in the process of creating value, then we will create job opportunity and create the wealth and improve our life, etc., and make every one of us enjoy our modern life, etc. Now come to this question, okay, what is manufacturing? If you ask this question to general public, I believe you will receive all kinds of answer, all right? Then what should be the accurate answer to this question? Now I'm going to play this video, and then you can try to formulate your answer to this question. Then later on, I will show you my version of answer. Then you can do a comparison, all right? Okay, so based on the observation from this video, I guess all of you may believe that you know the answer to this question of what is manufacturing. All right, so then actually it's very, very interesting for us to know what should be the most accurate answer to this question of what is manufacturing. It is interesting to know that actually the answer came from Lao Tzu's saying, right? And you know that Lao Tzu lived in the year around 500 before BC, 500 BC, right? And for those of you, if you know Chinese, so you understand this sentence of 一生二，二生三，三生万物, right? So basically it means one produce two, two produce three, three produce all, right? So that is a layman term, okay? In terms of answer to this question of what is manufacturing, all right? Then how to understand, okay, this sentence or this definition made by Lao Tzu with today's terminology in science and technology, right? And this is my version of interpretation of one produce two, two produce three, and the three produce all. All right. So this interpretation is very, very important for you to understand the true nature of manufacturing. All right. One produce two basically means all factor or all causes could be divided into two categories. One is inner law, and the second one refer to external condition, right? So in Chinese terminology, it means 内因, 外因, right? Inner cause or external cause, right? And two produce three means by combining these two type causes or factor, we are able to sustain three type of changes in the universe, all right? So these three type of changes include quantitative change, qualitative change, and fictional change, right? Then the combination of these three type of changes create all the things or all the object or all the entity in the universe. Okay, that means three produce all. All right. So that gives you a very, very scientific explanation to Lao Tzu's statement of one produce two, two produce three, and the three produce all. All right. So based on this understanding, immediately we could formulate the definition of manufacturing. So manufacturing basically means it is a system, right? Which will take a product join and the material as an input and produce a finished part or integrated part or integrated product as an output. And the most importantly, there are three types of manufacturing, all right? Quantitative change will lead to the so-called mechanical manufacturing, and the chemical manufacturing basically refer to qualitative change, right? And the largely overlooked manufacturing is this biological manufacturing, which refer to fissional change, right? So fission will lead to the so-called biological manufacturing. Today, when we talk about the manufacturing, when we talk about the industry, by default, in the mind of most people, okay, they refer to mechanical manufacturing and chemical manufacturing. So this is why biological manufacturing has been largely overlooked. And this is why we have this wrong interpretation about the evolution. Actually, evolution refers to biological production, all right? So this slide basically will help you to understand the nature of manufacturing and also the nature of another important topics, which is evolution, right? So this slide is very, very important, right? So since by default, okay, in our mind, manufacturing may means mechanical manufacturing or chemical manufacturing. However, the dominant conception or understanding is mechanical manufacturing, right? If we translate manufacturing in Chinese language, then immediately you understand we split manufacturing into two technical terms. One is to produce, another is to create. So you know, 制造, these are the Chinese word, right? 制 means to produce, 造 means to create, all right? And in English term, right, to create basically means what? To design, all right? To come out the design. To produce, it means what? To transform input into the output according to the design drawing, all right? So it's very important for you to understand the true nature of manufacturing, because in the mind of the general public, we always equal manufacturing to production. So manufacturing is not equal to production. Manufacturing include production and also include design and the marketing and the sale. Okay, so it's very, very important for you to know, right? And then how to produce, all right? Then how to create. To produce, for the first generation of industry, or even before the first generation of industry, we manually produce. That means we heavily depends on the human power or manpower. Okay, so then you will see, okay, normally to produce means to manually produce. Then how to create? To create basically means to mentally design, right? So design need to have mental capability. If you come out the drawing to design a car, to design a robot, it's not a simple task, right? So you need to have a lot of mental capability, right? So this helps you to understand, okay, the meaning behind the verb produce, the meaning behind the verb create, right? Then you can relate create to design and relate produce to make, right? We manually make something, we mentally design something, all right? So immediately you understand design, production are part of manufacturing. Okay, this is just to help you understand that the manufacturing include design. Manufacturing is not just production, all right? Okay, now I give you this example which help you to understand the big picture about the manufacturing. For example, if we have an idea of creating the result, okay, which can fly in the air, right? Then we must start with the design of this machine, right? Then followed by the production of this machine. Then after that, we must sell the result into the market. If we produce a result which could not be exchanged in the market, then we do not create any value at all, right? So from here, you will see that the manufacturing include design, production, marketing, and the sales, all right? And here is another example. If let's say we want to produce a machine which could be deployed in our home environment, all right? So to help us to provide the service or basic service in our home environment, then we must first design such a machine, then produce such a machine, and eventually to sell such a machine in the market. So again, you see design, production, marketing, and the sale, all right? These form three integrated part inside manufacturing, right? So this just help you to understand the difference between production and manufacturing, right? And this understanding will also help you to understand the shift of job scope, right? Because inside the production, you will see some work could be tedious for human worker to perform. Therefore, we must, okay, relocate the job scope from the production to design and to marketing and the sale, all right? So it could be more enjoyable for human being to undertake design, to undertake marketing and the sale, than undertaken dangerous, dirty, difficult job in production, right? So this helps you to understand why do we need to deploy robot in manufacturing. The answer is to free us from doing 3D type of a job inside production, all right? And then theoretically, what should be the big picture about the manufacturing? And this slide basically summarizes the blueprint of any manufacturing, right? So inside here, you will see the presence of a design, production, and the marketing and the sales. For example, we can talk about the design of the product, design of the process, design of simulation, design of supply chain, enterprise, etc. We group them all together, then you will see we land this integrated design as a virtual manufacturing, right? Then we can talk about the production process, transportation, and the inside the production process, we may have process equipment, metrology equipment, material handling equipment. Behind all this equipment, we can talk about the automation system. Inside automation system, we can talk about the control system, etc. If we group them all together, actually, this serve as the operating system of a factory. If we compare factory with a computer, I guess all of you know that the inside a computer, we have an operating system. Similarly, inside today's factory, they must be an operating system, right? But we do not use OS, okay, to name the operating system inside the factory. We use MES. So MES actually is equal to the OS inside computer, right? So MES stands for Manufacturing Execution System. Okay, so in layman term, you can just say or name it as the operating system of a factory. So it's easier for you to understand. Okay, so this piece of software, because all of you are familiar with the OS of a computer. Then what is OS of a factory? So MES. Right? So then you see the presence of a production. Then how about the marketing and the sale? Then you see this outbound logistic. So outbound logistic basically means what? Marketing and the sales, right? So output from your factory must distribute to the customer, consumer, etc. All right? So this is a typical scenario of doing marketing and the sales, all right? But of course, for inbound logistic, basically means you buy material, you buy component in order to transform them into the output of your company or your factory, etc. Right? So this slide gives you a full understanding of manufacturing from academic point of view. Right? So if you understand this slide, basically you understand the entire process inside manufacturing, right? And this slide will help you to have a intuitive visualization about this blueprint or generic blueprint of a manufacturing, all right? How to understand this generic blueprint, how to visualize it, then this slide help you to have a more intuitive interpretation of the generic blueprint of manufacturing. From here, you will see we have an inbound logistic, outbound logistic. That is the input to your manufacturing system, and output from your manufacturing system. Then inside, then you see the design, production. All right. So again, you see these three keywords: design, production, marketing, and the sale. All right. So then this is an intuitive way for you to see how could your company be organized. All right. So then once we zoom into the production, how will be today's production line looks like, right? Then this slide basically show you the important the process which is automation or feedback control loop, because in today's production line, okay, besides human labor, we heavily depends on the use of automated machine, and the inside automated machine we have a feedback control loop, and the inside the feedback control loop we have three important building blocks, okay, which are sensing, control, and actuation. All right. So these are the generic feedback control loop, which could be present inside any process, inside any equipment, inside any operation, etc. All right. So this slide basically gives you more detailed idea about the composition inside production line, right? And then I just quickly showing you some photo for you to understand the scenario of making product in the old day and the making product in today's industry. All right. And this slide basically help you to understand industry 1.0, because industry 1.0 make use of machine power or steam power, right, due to the invention of steam engine, right? So, and this steam engine was first adopted by textile industry, right? And then subsequently, we could make use of electric power to produce a product, and also invent the concept of a production line. So you will see this is a production line in which we must produce identical product. All right. Then in this case is automobile. All right. So these are identical product mass produced in the production line. All right. And today we heavily depends on the use of tools and the machine to produce a product. And this slide basically showing you a typical example of making use of a soldering device or welding device to join two work pieces together, all right? So this gives you idea about the invention of a tool, invention of a machine in order to accelerate the production of a product, all right, in our modern days, right? And this slide basically showing you the use of a machine, right? Besides the tool, we must have a machine which could be automatically operated, okay, by feedback control loop, right? Then in this case, we can automatically transform input. This is from here, you will see this is the input, then this is the output, okay? So then we can automatically transform the input material into the output material of a different geometry. All right, and in this way to achieve mass production by a station or by a production line. And here is the same. The roller could be under the control of a feedback control loop. Then in this way, we transform input into the output, because output has a specific geometry, and the input, you see there's no geometry. All right, so this is a typical scenario of a transformer input to the output, all right, by automated equipment or automated machine, etc. All right, this idea should be good enough for the general public to know, right? And today, of course, for a complicated process, then we can deploy more advanced machine, more advanced robot. So this is a typical scenario of making use of a CNC machine and the robot, and make these two types of machine to work together, all right, to achieve a full automation, all right. So here you see you have a numerically controlled machine, so we call CNC machine, and then here you see a robotic arm. So these are the two types of advanced machine or equipment inside a production line, all right. So then by making use of these advanced machine, we could achieve a mass production of identical product, right? And so from a previous picture, then you see there's an evolution, all right, from making use of human power to the use of machine power and then eventually robot power. Therefore, it is interesting for us to know, all right, the evolution of manufacturing history. All right, then you may want to know how is the history of manufacturing looks like, etc. Right. So this video may give you some idea, right, about the evolution of manufacturing history.
When the best companies couldn't even consider robots for their production line.
Welcome to EDIT Technology. I would like to introduce you to EDIT Technology into the world of robots, vision systems, and of course to vision-guided robots. EDIT Technology is the leader in this industry of small parts assembly and industrial robots. Nearly 50% of the 3,000 EDIT robot applications use an integrated vision system to ensure quality, flexibility, and a short return on investment. I think you will be surprised to see our robots handling and assembling and inserting parts that you come across in your daily life, like candies, sausages, CDs, and all kinds of consumer products.
Okay, so this should be good enough for you to roughly see the evolution of manufacturing from the use of labor or human power to the hybrid model, which make use of machine power, robot power, and human power, etc. Right? So actually, today we are in the era of Industry 4.0, right? Then you may want to know what is the Industry 1.0, what is the Industry 2.0, what is the Industry 3.0, right? Then what should be the better way for you to understand such evolution, all right? So actually you will see for Industry 1.0, we start to make use of mechanic power, steam power or steam engine actually produce mechanic power, because when there is a movement, all right, movement plus a force and torque, because force and torque times velocity equal to mechanic power, all right? So in layman terms, it is quite easier for you to understand, all right? So before Industry 1.0, we only make use of manpower or human power. Then with the introduction of mechanic power, we achieve Industry Revolution 1.0, right? Subsequently, we introduce electric power, okay? Due to the discovery of electromagnetic phenomenon, then we are able to make use of the electromagnetic principle to design electric motor. All right, so then we can make use of electric power, okay, to accelerate or to help manufacturing. Then we see the second revolution in industry. So that is Industry 2.0, right? Then with the invention of a computer, and in particular, the invention of a digital computer, all right? Then we can introduce computing power into manufacturing. Then we see the third revolution in manufacturing, that is Industry 3.0. And some of you may heard of this term or terminology, CIM, Computer Integrated Manufacturing, all right? And after the invention of a digital computer, there's another invention, that is a network, digital network. And also you see this World Wide Web, right? So, and the Internet of Things, etc. Right? So when we introduce networking power into manufacturing, then we see the fourth revolution in industry, that is Industry 4.0, right? So that gives you idea about the current history of manufacturing, right? And this slide give you one more, okay, interpretation or description about the current history of manufacturing, okay? And from Industry 1.0 all the way to today's Industry 4.0, right? So in short term, okay, you just consider that the Industry 1.0 make use of mechanical power. Industry 2.0 make additional use of electric power. Industry 3.0 make additional power, which is computing power, all right? And the Industry 4.0 make additional networking power, all right? Then what should be the Industry 5.0? The answer should be obvious, all right? So Industrial 5.0 should be manufacturing, which make use of additional robot power, all right? Okay, so, and this slide help you to understand the modern history of manufacturing from the viewpoint of energy. Just now, I already mentioned it, okay? The use of mechanical power trigger first revolution in industry. The use of electric power trigger the second revolution in industry, and the use of computing power trigger the third revolution in industry, and the use of networking power trigger the fourth revolution in industry. And by following this thinking, obviously you could make a prediction, right? The use of robot power will trigger the fifth revolution in industry, all right? And then this slide showing you the scenario of making use of manpower or human power, all right? So you see in this production line, a lot of workers work together, right? Then subsequently, we introduce additional electric power. Then in this way, we can automate certain type of things, right? And then we can first introduce additional computing power, right? Then we have smart machine, etc., right? And now today we introduce networking power, all right? And to link all the equipment together and synchronize operation among the different stations. In this way, we can minimize the wastage and maximize the output, etc., right? Then what should be the future? Okay, and the future actually is coming in, all right? It's very, very near to us already. So this is a scenario of making use of additional robot power, all right? So, and then from the viewpoint of a control, it is also quite easier for us to understand the evolution of manufacturing history, right? So you will see for Industry 1.0, we just make use of mechanical power, and this machine could not be called as a machine. They just is a kind of mechanized tool which make use of mechanical power, okay? Because the mechanized tool did not have computer did not have the brand, all right? Then for the second generation, we introduce a controller or feedback control loop, okay? So that trigger the second revolution in industry. At that time, the controller could be analog controller. There's no computer inside, but it's a simplified version of a brand, analog brand, all right? Then with the invention of a computer, then we enter the third era of manufacturing. That is digital control or computer integrated manufacturing. Okay, so for computer integrated manufacturing, we make use of a digital computer to serve as a digital controller, right? So we could digitally control machine, right? And today we are in the era of industry 4.0. Then we make use of a network. Then we can undertake a distributed control of a cluster of a machine and synchronize their operation. So then you see this network-based control. All right. Then what will be the future? So in future, we can let robot to control the entire production line. Right. It's also a distributed control, but at each node, we have a robot to do more advanced supervisory control, equipment control, process control, planning control, etc. Right? So you see this evolution. All right. So it means from the viewpoint of a control, and it's quite obvious for us to see, okay, that the industry 5.0 should be robot integrated manufacturing. Right? So now come to this conclusion or prediction, okay? Robot integrated manufacturing. Then you may want to know what is a robot integrated manufacturing. How does robot integrated manufacturing looks like, etc. Right? And again, what is the motivation for us to venture into industry 5.0, why the evolution will move in this direction, okay? Obviously, besides the viewpoint of a control, because these are the academic consideration, because this is in the university for the researcher, they believe, okay, look at the evolution of the type of a control, look at the evolution of a type of energy, for sure that the manufacturing will evolve into robot integrated manufacturing. So that is a viewpoint from researchers, scientists, all right? Then how about the viewpoint from a businessman, from people working in the industry? Are they convinced by this trend of evolving, okay, today's industry from version 4.0 to version 5.0, and believe that the version 5.0 will be robot integrated manufacturing, right? So first, let's look at the scenario, okay, about the robot integrated manufacturing, or let's understand how will robot integrated manufacturing looks like, right? Okay, so this short video may give you a rough idea about the future scenario of robot integrated manufacturing. And you believe that in such an environment, it will be more enjoyable for human worker to work inside because we delegate the 3D type of a job to robot to perform, right? Then in this case, human labor may enjoy their activity inside such a production line, all right? So now you may want to know, okay, why robot integrated manufacturing? Then we want to know, okay, the motivation in the business world or motivation from entrepreneur or from the market, etc. Right? So motivation number one in the business world or in the market should be the driving force for us, okay, to look for better product, right? And in future, okay, we always want to achieve product which must be smart, which must be network centric, which must be energy efficient, which must be small or compact, which must be environment friendly. These are the 5 driving forces for us to look for better product, right? So because we look for the emergence of better product, then automatically we must evolve the way for us to produce smart product, network-centric product, energy-efficient product, compact product, and environment-friendly product, right? So these are the demand from the business world, the demand from the economic sector, or from the society, from the consumer, right? So these are not the demand from professor, from researcher, from the scientists, all right, or from the academic world. From academic world, we know, okay, the evolution of the use of energy, the evolution of the use of a type of control, all right? That is professors thinking, scientists thinking, researchers are thinking, all right? Now you see, okay, there's also driving force in the market, from the consumer, okay, all right? So this is the first motivation for us to move into the era of achieving robot integrated manufacturing, all right? The second driving force also comes from the business world, right? So for the company owner, okay, or eventually for the shareholder, investor, etc., they always want to maximize the profit, minimize the expenses. Therefore, they always try to look for better technology, which will help investor, help the business owner to achieve or to maximize efficiency of company, of production line, etc. Right? So therefore, they always want to deploy advanced technology, okay, which will help them to reduce the cost. All right. Then in this way to maximize the benefit or maximize the profit, etc. Right. This is the second reason. Right. And the third driving force or motivation must come from consumer, because today when we mass produce identical product, then every people buy similar things, right? Actually, from the consumer's point of view, we always like to have a personalized product or customized product, etc. Right? And then how to balance the need to mass produce identical product and also the need to offer certain flexibility in order to meet the demand for personalized feature or customized feature. All right. So because there's a demand from the consumer, right? So therefore, we need to look for the possibility for us to accommodate, okay, these 4 types of conflicting requirement Because from the investor, businessman point of view, it is always good to mass produce identical product, because in this way the cost of production will be low. But from the buyer point of view, okay, we do not like to have an identical product, because everyone has an identical car, everyone has an identical handphone. It does not create much excitement. Okay, if we could order or buy, purchase, customized or personalized product, then it will be exciting, right? So how to accommodate these two types of conflicting demand, right? Solution is what? To have advanced manufacturing, all right, which will allow or accommodate mass production of individualized product. That means we produce a car, but all the car, maybe the feature could be random. Okay, no need to have identical color or identical feature, because we at the each station, eventually we can allow the customization. All right. But in terms of software, this is achievable, all right? Then in terms of the hardware, if we deploy a robot to undertake the task at the different station, then we could, okay, accommodate such scenario of mass-produced, individualized product, right? So this is another driving force from the demand of a consumer, from the demand of a businessman, investor, etc. Right? So, okay. So now you may want to know, is it achievable, okay, for us, okay, to offer, okay, robot integrated manufacturing, right? But we know, okay, from an academic point of view, there is such evolution. Then from the business world, from the market of a consumer, there is also such a driving force for us to move into that direction. Then you may want to know, okay, is it achievable, okay, to satisfy, okay, such a demand, okay? The answer is yes, all right? So I just quickly fly through some key technology which will enable us to achieve robot integrated manufacturing. The first one is automatic feedback control system, all right? So with the discovery of a control theory, or with the development of a control theory, today we can design all kinds of feedback control loop. So with the use of a feedback control loop, we can achieve many automated system, automated machine, right? And also with the invention of advanced sensor, and we can let machine to achieve a high level of perception capability, and also let the robot to plan low-level activity, right? Then in this case, we could achieve intelligent automation system, right? Today, we have such a technology, so it's not an issue. And most importantly, with today's advance in robotics technology, right? We have a full understanding about the working principle behind different module inside a robot, all right? For example, from motion planning to motion analysis, all the way to the motion control and the motion simulation and the robot design, all right? So if you understand this slide, so basically you understand the entire theory of robotics, right? So robot basically will take a task as an input, then we can decompose the task description all the way to the equation of the motion. And the equation of the motion will be the input to the motion control loop inside the robot. Then output from the motion control loop inside the robot will be the performed motion. If the performed motion meets the requirement of intended task, then the robot will be able to perform any intended task. So that is the working principle, right? Today, we have all the technology, all the theory for us to implement this blueprint of today's robot, right? And therefore, with control technology, control theory, with sensor technology, perception theory, with robot technology and robotics theory. So actually, we are ready to massively deploy robot in manufacturing, right? So this slide basically highlight to you the 4 major areas in which we could massively deploy robot. For example, we can deploy robot to undertake material handling. We can deploy robot to undertake shape forming. We can deploy robot to undertake all kinds of process operation. We could also deploy robot to undertake all kinds of surface treatment in production line or in manufacturing. All right. So in this way, we could achieve or accommodate the conflicting demand, all right, of quantity, quality, and customization, right? So with robot integrated manufacturing, eventually we could mass produce product with a high quality, with a high level of diversity in terms of products feature, right? So big quantity, high quality, and diversity in customized feature, product feature, right? And also with robot integrated manufacturing, additional benefit is to free us from doing 3D type of a job. Then in this way, we can depends on the use of robot power to create the wells, right? Instead of heavily depends on the human power to create the wells. Because the wells created by robot could be distributed among citizens, among the population. Therefore, we do not spend too much time in manufacturing. And then in this way, we may have more time to enjoy our life, all right? And to have more time to spend in doing learning, in doing entertainment, and in doing traveling with a family, etc. All right. And most importantly, with the massive deployment of a robot in manufacturing, eventually we can create new type of a job. For example, tomorrow's robot may need to have a service provider to help them to do installation, to do maintenance, to do servicing, and to do repair, etc. So it's like we have a medical doctor for human being. Eventually, we may have a medical doctor for robot channel, right? And also, for human being, we spend 10 years, 20 years in the school with the help of a teacher. So we have a teacher to teach human being. And in future, we may have a lot of teacher for robot to teach robot, etc. All right. And another interesting scenario may be for those of you, if you are interested in creating or in spending more time to create the wealth for the society, then you could become an employer of a robot, all right, to sustain the creation of the wealth for the society, then distribute the wealth in a certain way, a certain new way, okay, among all the population, among the citizens, etc. So you will see the Industry 5.0 eventually may trigger some changes, okay, in the governance of our society, in the governance of our economy, etc. All right. And now I just going to show you some typical activity which could be undertaken by robot autonomously, right? So this is a pick and place. And this is another scenario of doing sorting, right? So your one robot pick up the white color part, another robot pick up the yellow color part. So for this type of operation, you see a machine need to have a certain level of intelligence, right? Okay. And this is a cooperation in doing welding. So two robots work together like a weld a common work piece. And you see the flexibility to be performed by today's robot, right? And this is a dirty job, right? So we can let the robot to do the painting because the painting is dirty and also dangerous because the smell, the vapor is harmful to human beings' health. And this is a difficult job, right? If let's say we do the pick and place material handling of a heavy object, then for a human being, it could be very, very tiring for us to continuously to work in such a station for a few hours, right? So then we can let robot to undertake such a difficult job, right? And this also is a difficult job, right? If let's say we do some collaboration or to do some very complex task, right? So 3 robotic arms work together, right? And we can achieve a high precision, high accuracy in terms of motion control, right? This also is a very, very difficult task. You see, the object is very, very heavy. It's not possible for a human being to carry such a heavy payload, right? And to still perform a very smooth motion, right? And now I'm going to show you a short video about the industrial project that we have done in China. So you will see the major production activity is undertaken in China for the manufacturing of ceramic-like utensil, right? And this environment is quite difficult for human being to work due to the high temperature and due to the presence of powder in the air, right? The machine, we have this compressor, the temperature could reach 200, 300 degrees. And this is a process which transforms input material in the form of a powder to the output material in the form of a solid, right? So, and these kinds of industrial have a lot of trouble in hiring human worker. Even you increase the salary, and after 6 months, all the human worker will quit such a job because it is quite harmful to the health of a human worker, all right? Then we managed to help them to develop a robot to free human being from working in such an environment. Then from here, you see in the production line, we can deploy, okay, a robot to free human being, right? And how will each robot works, all right? And this video basically showing you the automated process with the use of robot designed by us. So from here, you will see the input is material in the powder, all right? And in such an environment, you will see in the air, we have such a lot of particles of such a powder. And these particles are harmful to the lung of a human worker. Then we try to transform material from a liquid state or from a solid state or powder state into liquid state, and from liquid state to solid state, okay, by controlling the temperature. right? So the temperature could reach 200 degrees, 300 degrees. So this is a very, very hot environment, right? Because inside the material will be transformed from powder into liquid, liquid back to solid, right? For the output of a utensil, because utensil has a surface with a colorful painting. So actually, we print the painting on special paper. This paper could be incorporated inside the solid, right? Yeah. Then the last process is to apply a special powder. Okay, this special powder once become liquid, then become solid, will produce a surface, a shiny surface. Okay, on top of the utensil. Then you see the output from this process. After that, then we just polish the edge of the utensil, right? So this is the station which will produce two display at the each time, right? So then we just repeat, etc. Okay, so then you see actually for today's existing manufacturing process or production station, we can slowly, okay, free human being from doing 3D type of a job, right? Now I'm going to show you the evolution of a production line in the automobile industry. And this video will show you the massive deployment of a robot in the production line of Mercedes-Benz company. All right. So from this video, you will see that the robot integrated manufacturing is near us already, is coming soon, all right? And some leading company have already adopted this evolution, all right? And there you see the massive deployment of a robot in the production line of some leading company, right? So this is not very far away from us, all right? So it's coming soon, right? Okay, so that's all for my today's talk, all right? So I hope, okay, by listening to my talk, you will believe that the industry 5.0 is near us, and the industry 5.0 should be robot integrated manufacturing, all right? And hopefully from the listening of my talk, you roughly understand the nature of robots, the nature of robotics, and in particular, I hope that you have again a better understanding about the nature of manufacturing. In particular, you understand that there are three types of manufacturing. They are mechanic manufacturing, chemical manufacturing, and biological manufacturing. And interestingly enough, the understanding of biological manufacturing will help you to understand the nature, the true nature of evolution, all right? And lastly, I hope that you will be convinced, okay, by the future trend in manufacturing, which is to transit from Industrial 4.0 to Industrial 5.0, and the Industrial 5.0 should be robot integrated manufacturing. Thank you for your attention. And now I'm ready to take a few questions from the audience.